Hello, everyone. If someone who's looking for the detailed walkthrough of the Cambridge IGCSE paper code 0580 paper 2 for May June 2024, then you're in the right place. So stick around and learn how you can solve all of these questions in a quick way and save time when you're giving the paper. So let's go. Question 1 says write the number 2,002,002 in figures. So a million has 6 digits or like 6 zeros. So 20 and 2002 is going to be like this. So 2002. And since a million has 6 digits, so 0, 0 over here and 2. So 2,002,002. That is your answer. Next question says put one pair of brackets into this calculation to make it correct. So we have 5 minus 4 times 3 minus 9 minus 2 equals 0. So we're supposed to put brackets around 2 digits or more than 2 digits to see what gives us 0. So what you're going to do is that if you put the brackets around these numbers, we can see that 4 times 3 is 12. So you have 12 minus 9 over here, minus 5 minus 2. 12 minus 9 is 3. So 5 minus 3 minus 2. So 5 minus 3 minus 2 is 0, which is exactly what the equation asks us to prove. So the brackets are going to be around 4 and 9. Just remember when you're solving such questions, remember the rules of BODMAS, that you solve the bracket first. Inside the bracket, if there's multiplication and division, along with addition subtraction, you do multiplication division first, and then addition subtraction. Question 3 says simplify 7x minus 8y minus x minus y. So we're going to combine the like terms. 7x and negative x are like terms. Negative 8y and minus y are like terms. So 7x minus x minus 8y minus y, which is basically 6x minus 9y. That is your answer for this one. Question 4 says the base of a cuboid measures 10 centimeter by 7 centimeters. The volume of the cuboid is 280 centimeter cube. Calculate the height of the cuboid. So to calculate the height of the cuboid, you need to know the formula for the volume of a cuboid. Volume of a cuboid has the formula of length times width times height. That's going to be 280 equals to 10 times 7 times h, which is your height. So 280 equals to 70 times h. 280 divided by 70 equals to h, which is 4 centimeters. So that's your answer. Question 5 says, in a city, the probability that it will rain today is 0.15. Find the probability that it will not rain today in the city. So if the probability of raining is 0.15, to find the probability of not raining, we're going to do 1 minus 0.15, which is equal to 0.85. Always remember when you're trying to find the probability of an event not happening and the probability of that event happening is given, you subtract that probability from 1 and you get the probability for the event not happening. Question 6 says factorize completely. So we need to see what's common between both the terms. Between 4x squared y and 5xy squared, we can see that we have x and y common. So when we take x and y common, which is the greatest common factor over here, what we're left behind with is 4x minus 5y inside the bracket. As you can see, we cannot further break this down because they don't have anything in common. We can't apply difference of perfect squares, so we leave it at this. So xy times 4x minus 5y is your answer. Question 7 says the scale of a map is 1:40,000. On the map, the distance between two villages is 37 centimeters. Calculate the actual distance between the two villages, giving your answer in kilometers. So what we're going to do is that we can see from the scale that 1 centimeter equals to 40,000 centimeters. So let's first multiply 40,000 with 37 centimeters to have the actual distance in centimeters. That's going to be 40,000 times 37, which is going to give us 1,480,000 centimeters. So now in kilometers, we will divide this by 100,000. Why will we divide this by 100,000? Because 1 meter is 100 centimeters. 1 kilometer is 1,000 meters. So to convert the kilometer into centimeters, you multiply 100 by 1,000, which is 100,000 centimeters. So now since we're going from centimeter to kilometers, we're going to divide the distance by 100,000 instead of multiplying. And that is going to give us 1.48 kilometers. So that is your 14.8 kilometers. That is your final answer. Question 8 says, without using calculator, work out 3/7 minus 1/14. So in this case, you need to remember that whenever we're adding or subtracting, unlike denominators, the first step is to make the denominators equal. As you can see, for the first fraction, the denominator is 7. And for the second fraction, the denominator is 14, which means we will multiply the first fraction by 2. Why? Because 2 times 7 is 14. And remember, when you're trying to make the denominator equal, you're going to multiply the numerator by the same number as well. That is exactly why we're multiplying 3 by 2 as well. So now we have 6/14 minus 1/14, which is basically 5/14. Because since the denominators are equal, we can combine it as a single fraction and subtract the numerators. So 6 minus 1/14, which is 5/14. Since we cannot further simplify it, this is your final answer. Question 9 says the diagram shows a right angle triangle. Calculate AB. So AB is basically this length over here. We have this and we have this. So to calculate AB, what we're going to do is that we're going to use SOHCAHTOA. Now, why are we using SOHCAHTOA? We're using SOHCAHTOA because Pythagoras theorem cannot be applied over here because we have just one length. Pythagoras theorem is only applicable if we have a right angle triangle and if we have two lengths given and the third one is missing. So since we only have one given length, Pythagoras theorem is out of our options. Next thing we can apply in right angle triangles is SOHCAHTOA. So for SOHCAHTOA, we need to know which one of the trig ratios can we apply. Can we apply sine, cosine, or tangent? If you remember SOHCAHTOA, for SO, it means sine equals to opposite over hypotenuse. For cosine, it's adjacent over hypotenuse. And for tangent, it's opposite over adjacent. Now to figure out what information they've given us, do we have the opposite? Do we have the adjacent? Or do we have the hypotenuse? Hypotenuse is always the diagonal, always. Adjacent is the line on which the angle lies. So since the angle lies on AB, so AB is the adjacent. And opposite is the length opposite to the angle, which makes AC our opposite. So now as you can see, we have the hypotenuse, we have the angle, and we're trying to find the adjacent. Hence, we're going to use cosine. Cos of 37 equals to AB over 8. So 8 times cos of 37 equals to AB. You will plug this in the calculator, and what you will have is 6.39 centimeters. That is your length of AB. Question 10 says, find the gradient of the line joining the points -2, 7 and 3, 1. So gradient basically is denoted by the variable m. And m has the formula of y2 minus y1 over x2 minus x1, which is basically change in y over change in x. So you can call this x1 and y1 and this x2 and y2. Always remember, if you're picking a coordinate and you're assigning x1 to the x value, so then the y value would also be y1. It won't be y to x1 and y2. That's incorrect. So x1 and y1 come together, x2 and y2 come together. So that's going to be 1 minus 7 over 3 minus -2, which is going to be -6 over 3 plus 2, and that's -6 over 5. So that's your gradient joining the points given in the question. Question 11 states, solve the simultaneous equations. So we have a system of simultaneous equations where the first equation is 5t minus 2w equals to 19, and the other is 3t plus 2w equals to 5. So we have to find the value of t and w. I'm going to use elimination method for this system because it's going to be easier, because for substitution, you need to make one of the variables subject, then substitute it in the other equation, and then solve it. Since in this system, they haven't already made any variable the subject, so it's going to be an extra work for you. So to avoid that, just go for the elimination method, pick the variable you want to eliminate, and then start solving it. I'm going to eliminate w over here. Now, the reason why I'm going to eliminate w, because if you look at w in both the equations, w has the exact same coefficient, which means another step is cut out from the calculation. So that makes it easier. We don't have to make the coefficients equal. Since the coefficients are equal, now we look at the sign of the variable that we want to eliminate. W is negative in the first equation and positive in the second equation. So since they have opposite signs, in order for us to eliminate W, we will have to add the two equations. So by that, what I mean is that 5t minus 2w equals to 19, 3t plus 2w equals to 5. And if you add the two, 5t plus 3t is 8t. Negative 2w plus 2w is 0. As you can see, we have eliminated w. And 19 plus 5 is going to be 24. Hence, 8t equals to 24. T equals to 24 divided by 8, which is equal to 3. Now that we have the value of t, what you can do is to find the value of w, you can substitute t equals to 3 in either of the equations. I'm going to pick the second one because that's going to be easier to solve. And it's going to be less time consuming, which is what your goal should be. So 3 times 3 plus 2w equals to 5. 3 times 3 is 9. So now we're going to move 9 to the other side. 5 minus 9. And that's -4. So w is -4 over 2, which is -2. So when t is 3, w is -2. And that is your answer for this question. Question 12 says simplify. So this is a question for the rules of indices. So you need to remember, when you're multiplying similar bases, like for example, if you're doing a to the power of m times a to the power of n, you will add the powers. And if you're dividing them, you will subtract the powers. Over here, g to the power of 16 is being divided by g to the power of 8. G is a similar base, and since the similar bases are being divided, you will subtract the powers. First, for the variable, it's going to be 16 minus 8. Now, for the coefficients, you simply divide 32 by 16, which is 2. So 2 times g to the power of 16 minus 8, which is 2 times g to the power of 8. And that is your answer. In the next part, we have 625k to the power of 8 whole power 3 by 4. So this is another rule of indices. So whenever you have a power inside the bracket and a power outside the bracket, in order for you to solve it, you multiply the powers. Now the power will get distributed on not just the variable, but also on the coefficient. So it's going to be 625 to the power of 3 or 4 multiplied by k to the power of 8 whole power 3 over 4. Now 625 is basically 25 times 25. And since 25 is 5 squared, 625 is 5 to the power of 4. So replace 625 with 5 to the power of 4. And over here, we can expand the bracket by multiplying the powers. So 8 times 3 by 4. And over here, 5. For 5, it's going to be 4 times 3 over 4. So now if you simplify the powers, what we will have is 5 to the power of 3 times k to the power of 6. 5 to the power of 3 is 125. So 125k to the power of 6 is our final answer. Question 13, A says shade the region A union B complement. So A union B complement is going to be everything that is not a part of B. So that's going to be A and outside of A. Then part B says use set notation to describe the region given the question. So the shaded region given the question is going to be R intersection P union Q complement. Why? Because we can see that P and Q are not shaded at all, which means P and Q are not a part of the shaded region. So that means it's going to be a complement for that. So P union Q complement intersecting with R. So that's your answer. In question 14, it says that PQR and T are points on the circle. AB is a tangent to the circle at T. Angle ATP is 50, which is basically this angle. And then PTR is 48. So that's going to be this one. PQ equals to QR. Find the angle PRT. So they're asking us to find this angle. So to find this angle, what we're going to do is we're going to use the alternate segment theorem. Now the alternate segment theorem says alternate segment theorem. So based on the alternate segment theorem, this angle is basically equal to this angle, and this angle is basically equal to this angle. So if this is 50, PRT is also going to be 50 degrees. Then the next part says find angle QPR. So to find angle QPR, this is the angle that we're supposed to find. So we know this is 50. And as you can see, PQRT is a cyclic quadrilateral. So a cyclic quadrilateral has opposite angles. So in a cyclic quadrilateral, opposite angles add up to 180. Which means whatever this angle is, this angle plus 48 equals to 180. So angle PQR plus 48 equals to 180. So angle PQR equals to 180 minus 48, which is basically equal to 32 degrees. So this is 32. So now to find QPR, we can see that QPR is a isosceles triangle. So in an isosceles triangle, two lengths are equal and the opposite angles are also equal. So which means this is equal to this. And we will do for QPR 180 minus 32 divided by 2. QPR is an isosceles triangle and the sum of angles for triangle is 180. So 180 minus 32 divided by 2 gives us 24 degrees. And that's your answer. For question 15, we have a cumulative frequency graph. It says the time taken for each 200 students to complete a calculation is measured. The cumulative frequency diagram shows the results. Use the diagram to find an estimate for the interquartile range. So for the interquartile range, we need the lower quartile and the upper quartile. So for the lower quartile, we find 1/4 of the total cumulative frequency, which is 200. So that's 50. Upper quartile, we find 3/4 of 200, which is going to be 150. So basically, we need the 50th value and we need the 150th value. So for that, draw a line from 50 towards the graph. And from 150. This and this. So that's basically 20, 19, 18, 17, 16. And that's 30, 19, 27. 1, 2, 3, 4, yeah. So the interquartile range is going to the difference of 27 and 16, which is basically 11. Then part B is the number of students taking more than 40 seconds to complete the calculation. So for more than 40 seconds, you draw a line from 40 towards the graph. And we can see that it's 181, 2, 3, 4, 5. So between 200 and 180, basically for the scale factor of this, it's going to be 20 divided by 5 because there are 5 squares between 0 and 20. So that's 4. So each small box equals to 4. That's 184, 188, 192, then 196. So between 192 and 196, that's 194. So the number of students are 194 for this. So now for the number of students, what we'll do is we will subtract 194 from 200. And that's basically 6. So 6 number of students are taking more than 40 seconds to complete the calculation. Question 16 says rearrange the formula to make H the subject. So right now A is the subject of this formula and they want to make H the subject. So what we're going to do is that we're going to first move pi r square to the other side. So it becomes A minus pi r square equals to pi times d times H. Since H is supposed to be the subject, I'm going to move pi d to the other side. And when you move it to the other side, instead of multiplying A minus pi r squared, it's going to divide the expression. Now remember this rule that when you're moving terms from one side to the other, the operation it's performing changes. Like for example, we started with moving pi r square to the left-hand side. When we move it to the left-hand side, instead of adding to a, it was subtracting from a. Similarly, when we move pi d to the other side, instead of getting multiplied to a minus pi r square, it's dividing a minus pi r square. So as you can see, it's doing the opposite thing. So h equals to a minus pi r square over pi d. Seventeen says, work out giving each answer in standard form. So what you can do is that you can multiply 2.1 by 8. So 2.1 times 8 times 10 to the power of 101 times 10 to the power of 101. So 2.1 times 8 is 16.8. And 10 to the power of 101 times 10 to the power of 101 is basically 202. Why? Because remember, when we're multiplying similar bases, we add the power, which we did in the previous question. So when we add the powers, we get 10 to the power of 202. Now it says standard form. In standard form, your decimal comes after the first digit, not the second or the third. So to make sure it comes after the second digit, we will move the decimal one place to the left. And for that, need to add 1 to the power. So now instead of 202, we have 203. So 1.68 times 10 to the power of 203 is your answer. For part B, it's 2.1 times 10 to the power of 101 plus 2.1 times 10 to the power of 100. So over here, we can see that 2.1 times 10 to the power of 100 is common. So what we're left behind with in the bracket is 10 plus 1. So now 2.1 times 10 to the power of 100 times 11. So now if we multiply 2.1 with 11, that gives us 23.1. So 23.1 times 10 to the power of 100. Same thing, we have to move the decimal one place to the left. So that's after the first digit, not the second. So that's going to be 2.31 times 10 to the power of 101. Why? Because since we're moving it one place to the left, we're adding 1 to the power. If we're moving it one place to the right, then you would be subtracting it. So 101 over here. Question 18 says the diagram shows two sides, VA and VB, of a regular polygon. AVX is a straight line. Angle BVX is Y and angle AVB is 11.5 Y. 11.5 Y and BVX is Y. We need to find the number of sides of this polygon. So since AX is a straight line, we can add up 11.5 Y and Y, put that equal to 180 to find the value of Y. So that's 12.5 Y equals to 180. Let's divide 180 by 12.5 Y. Let's divide 180 by 12.5. And that is going to give us the value of 14.4. Now this is just Y. We need to find the number of sides. So since Y is our exterior angle and 11.5 Y is our interior angle, we can use either of the formulas to find the value of the number of sides. I'm going to go with exterior angle because that's simpler. N equals to 360 divided by the exterior angle, which is Y in our case. So N equals to 360 divided by 14.4. And that is going to give us the value of 25. You could have used the interior angle formula as well, but like that would have been a lengthy calculation. And once again, our goal is to save time. So let's just stick to the exterior angle one. Question 19 says, describe fully the single transformation that maps triangle T onto triangle W. As you can see, there's a change in the direction of the triangle. So which means there's a rotation. And since the size of the triangle is exactly the same, that means there's no enlargement. And there's no translation as well, because in translation, the direction of the shape is exactly the same. That's not changing. So it's a clockwise rotation. And since it's in the next quadrant, it's 90 degrees. Now to figure out the center, I'm going to join the relevant points with each other. And if we draw a straight line passing through this, which will be perpendicular to all of these points, that line passes through 0, -2. So this is your center of rotation. Second, it says draw the enlargement of triangle T with scale factor -2 in center of enlargement -1, 1. So -1, 1 is over here, and the scale factor is -2. If the scale factor is -2, that means the shape is going to be over here in the negative quadrant. So to look at the distance of this point, let me give this a different color. This point from the center, we can see that it's 1 unit vertically and 2 horizontally. 2 horizontally. So where if you're going to do 2 vertically now, because the scale factor is 2. -2, sorry. So it's going to be 2 vertically now, and 1, 2, 3, 4. 4 horizontally. Same for this point over here now. Now this is 2 horizontally, but 1, 2, 3, 4. 4 vertically. So now that is going to be 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. That's over here. Then for this point, it's 1, 2, 3, 3 horizontally and 4 vertically. So for 3 horizontally, it's going to be 6 now. 1, 2, 3, 4, 5, 6. And then it's 5. It's 4, so 8 down. So it's going to come over here. So now when you join the points, this is the enlargement by scale factor of -2, because you can see that this distance was 1, now it's 2. This was 3, this is 6 now. This is 3, this is also 6 now. So that's your answer. Question 20 says f of x equals to 3 to the power of x plus 2. Find x when f of x equals to 245. So 245 equals to 3 to the power of x plus 2. We take 2 to the other side. So now it's 245 minus 2. 245 minus 2 is 243. So now using trial and error, we can find that 243 is basically 3 to the power of 5. So whenever the bases are same, you can put the powers equal to each other on both sides. Like if there's just like one base and one base on each side, which is also one of the rules of indices, which means x equals to 5. Next part says find x when the inverse of x equals to 7. So to find the inverse of x, we put the original function equal to y. So y equals to 3 to the power of x plus 2. Bring 2 to the other side. Y minus 2 equals to 3 to the power of x. Now over here, we can see that this is an exponential function. In order to make x a subject, we need to convert this exponential into a logarithm. So this is going to be log of y minus 2 to the base of 3 equals to x. This is the conversion from an exponential to logarithmic form. So we use that conversion. Your base of the exponent becomes the base of the log, and your power of the exponent becomes the subject of the equation. So as you can see, x is subject now instead of y, and that is the goal that we're trying to achieve and trying to find the inverse of a function. So now we can replace x with f inverse x and replace the y in the function with x. So it becomes log of x minus 2 to the base of 3. Put this equal to 7 because trying to find the value of x again. Now, once again, we're going to convert the log to exponential form. Go the other way around. Now it's going to be 3 to the power of 7 equals to x minus 2. 3 to the power of 7 is 2187 equals to x minus 2. So x is going to be 2187 plus 2, which is 2189. That is your answer. Question 21 says, write the recurring decimal 0.41 as the fraction in its simplest form. You must show all your working. So what we're going to do is, first we're going to assume that x equals to 0.41 recurring. Now what I'm going to do is, I'm going to multiply x with 100x. So when I multiply x with 100x, that makes 0.41 recurring into 41.41 recurring. Now, the reason why I'm multiplying it by 100 is because I'm trying to get rid of the numbers after the decimal so that it's easy to convert it into a fraction. So what we're going to do is now we're going to multiply x with another number, 100, 1000, 10, whatever that suits the equation, and make sure that whatever we multiply it with, the number after decimals are same in both cases. So I'm going to multiply this by 10,000 now. Now multiply x by 10,000. It's going to be 4141.41 recurring again. So as you can see, the numbers after the decimal are exactly equal. So since they're equal, it's easier to eliminate them because what I'm going to do next is that I'm going to subtract 100x from 10,000x. So when I subtract 100x from 10,000x, these are also going to get subtracted because we're assuming that 100x equals to this and 10,000x equals to this. So now that's basically going to be 9900x, and this is going to be 4100. As you can see, the recurring numbers after decimal are completely gone. So now x is going to be 4100 divided by 9900. Cancel out the zeros, and 41 over 99 is your value of x. This can't be further simplified, so this is the final answer. For this question, just remember the steps. It's pretty simple, and it's pretty scoring. So if you know the steps, you're good to go. Question 22 says, solve the equation tan x plus root 3 equals to 0 for x greater than equal to 0 and less than equal to 360. So tan x equals to negative root 3, x equals to tan inverse of negative root 3, which is basically negative 60. So tan is negative in the second quadrant, and tan is negative in the fourth quadrant. So x is going to be 180 minus 60, which is 120. That is the first value. And then x is going to be 360 minus 60, which is 300. Negative 60 was not the answer because that's a negative value, and the given range is positive 0 to 360. Hence, 120 and 300 is the answer. Next question says that simplify 2 over y plus 1 minus 3 over y, giving your answer as single fraction simplest form. So as I said earlier, when we're adding or subtracting, unlike denominators, we have to make the denominators equal first. So we multiply the first fraction by y, both the numerator and denominator, and the second fraction by y plus 1. So that gives us 2y over y times y plus 1 minus 3 times y plus 1 over y times y plus 1. As you can see, both the numerator and both the denominators are equal now. So we can rewrite this as a single fraction, y times y plus 1. And the numerator would be 2y minus 3y minus 3. So 2y minus 3y is negative y. Negative y minus 3 over y times y plus 1. And that is your answer in its simplest form. Question 24 says the diagram shows a triangular prism with cross-section triangle BCV. Angle BCV equals to 90, BC is 5, CV is 4, and AB is 15. Calculate the angle between AV and the base ABCD. So basically, they're asking us to calculate this angle over here. So to calculate this angle over here, to calculate the angle over here, we need AC. And AC can be found using Pythagoras because this is a right angle triangle. So AC is going to be square root of 15 square plus 5 squared, which is basically equal to square root of 250, and that equals to 15.81 centimeters. Now, this is 15.81. We have the length over here. This is another right angle triangle. So I'm going to use tan of A, because this is the angle that we're trying to find, equals to opposite, which is 4, divided by the adjacent, which is 15.81. So A equals to tan inverse of 4 over 15.81. And that is going to give us 14.19 degrees. This is the angle between AV and the base ABCD. Remember, if you're struggling with understanding which one's the opposite, which one's the adjacent is the length on which the angle lies, and opposite is the length opposite to the angle. So that's why 4 is opposite and 15.81 is your adjacent. Next question says that simplify pt minus p minus t plus 1 over 1 minus t squared. So divide this into two groups. Pt minus p is one group, minus t plus 1 is another group. So if you look at the first group, between pt minus p, we have p common, so t minus 1. And between negative t plus 1, we have negative 1 common. So once again, that's t minus 1. And the denominator, we can see that we have a situation of perfect squares. And we know perfect squares, when they're being subtracted, they can be expanded to this format. So over here, our A is 1 and B is t. So it's going to be 1 minus t times 1 plus t. So in the numerator, we can take t minus 1 common, and we're left with p minus 1 in the other bracket. So we have 1 minus t and 1 plus t. Now what we can do is, we can take negative sign common in the numerator from t minus 1. So when you take that negative sign common, that becomes negative 1 times 1 minus t times p minus 1 over 1 minus t times 1 plus t. As you can see, there's a 1 minus t in the numerator and denominator. So we can cancel it out and we're left with negative 1 times p minus 1 over 1 plus t. So minus 1 times p is negative p, and minus 1 times negative 1 is plus 1. So negative p plus 1 over 1 plus t is your final answer. Question 26 says, in the diagram O is the origin, OP equals to P, OQ is Q, R is the point of intersection of PQ and OS, with PR is to RQ is 1:2, and OR equals to RS. Find the position vector of S in terms of P and Q, giving your answer in its simplest form. So what I'm going to begin with is that I'm going to begin with writing down the vectors that we have. OP is P, OQ is Q. So we can begin with finding PQ, which is going to be PO plus OQ. Why? Because we go from here, then we go to here, and that gives us PQ. So if I draw the arrows, go from here to here, P to O, O to Q, that's the same as PQ. So if OP is P, PO is negative P. Why? Because we're changing the direction of the vector now. So if you change the direction, the sign changes. And OQ remains the same, which is positive Q. Next, what I'm going to find is I'm going to find PR. Now, PR is going to be 1/3 of PQ. Why 1/3 of PQ? Because it's said that PR is to RQ is 1:2. So this is 1/3 of PQ, and this is 2/3 of PQ. So 1/3 of negative P plus Q. So RQ is going to be 2/3 of negative P plus Q. Now, next, I'm going to find OR. So to find OR, I'm going to use OP to PR because we have these two vectors, so it's ideal that we use this direction to find OR. So OP plus PR. So that is going to be P plus 1/3 of negative P plus Q, which is basically equal to 3P minus P plus Q over 3, which is 2P plus Q over 3. That is OR. Now, OR is equal to RS, so RS is also 2P plus Q over 3. Now, as you can see, OS is the sum of OR and RS. So I'm going to write this over here. OS is twice of 2P plus Q over 3, which is 4P plus 2Q over 3. That is your position vector for S in terms of P and Q in its simplest form. If you're still confused by this question, hit me in the comments below and try to explain it again because I know the working is a little bit squiggly at this moment because there's a lot going on, but I am open to explain it again.